Welcome to Transmathematica. I'm James Anderson. Today we're going to discuss the NaN equals nullity lie. Transreal arithmetic defines nullity as the unique fraction nullity equals 0 over 0. The IEEE 754 standard for floating-point arithmetic defines a class of non-numerical objects, NaN sub I. We need the subscript I to distinguish the many different NaNs. The lie is that Transreal arithmetic is the same as the 1985 version of the standard, in particular that NaN equals nullity. Transreal arithmetic was formalised in 2007 and the 1985 version of the standard is the only one that was in scope. The nastiest version of the lie is the accusation that Transreal arithmetic plagiarised the floating point standard, and this accusation is made anonymously and no evidence is offered to support it. The claim is obviously a lie. Anyone who has read the standard and read Transreal arithmetic knows that they are very different things with very different histories. So, how do I defend myself against anonymous people who offer no evidence? Well, the best thing I can think of is to accuse the liars of lying and give fair evidence. And that's what this video is about. I'm going to give fair evidence comparing IEEE 754 and Transreal arithmetic. The lie comes in many different forms. One of them is to obstruct publication of Transmathematics. Now, I have no problem with Transmathematics papers being rejected. My own journal rejects some of my papers. I do object to people committing scientific fraud in order to repress publication. I can't stop that from happening. I usually don't know who's doing it and when. At best, I find out later. And this is a fairly common occurrence in the history of science, and there are some standard ways of dealing with it. So if you are a young scientist who is facing these problems, you might like to know how your predecessors have dealt with it. And what they do, what I did, is set up a journal. There are many areas of mathematics that have been preserved to the present day because the person creating that mathematics owned or edited a journal. The second thing you can do is publish books. Books can be read anywhere in the world. They can be preserved in libraries. In the modern day, I can publish on a YouTube channel. YouTube channels are short-lived, but any defense is better than none. Another version of the lie is to delete evidence for Transreal arithmetic. This is usually done by deleting information from websites. Occasionally it is done in other ways. And there are the usual defenses against this. The first is to publish in any archival journal. Transmathematica is an archival journal. Publish anywhere in the reputable scientific literature, and your paper will be archived indefinitely. The next defense is to deposit paper copies of books with a copyright library. In the UK, this is the law. If you produce a book, you have to submit it to at least one of the 5 copyright libraries, and they will preserve it indefinitely. And the third defense is to gain international supporters. Easier said than done, but having knowledge of the mathematics spread across the world makes it harder to repress. So let's move on to the comparison between floating-point arithmetic and transreal arithmetic. And I want the comparison to be fair. So the first thing I need to do is set out fair grounds for the comparison. The first thing I'm going to do is ignore differences due to IEEE 754's finite approximation of real numbers. Those differences are not relevant to the structure of floating-point arithmetic and transreal arithmetic. I'm going to assume that IEEE's infinity corresponds to transreal infinity and that IEEE's minus infinity corresponds to transreal's minus infinity. And finally, I'm going to assume that each NaN corresponds to transreal nullity. So each one of the many NaNs corresponds to transreal nullity. If you can think of more or better grounds for the comparison, then do put them in the comments below. Now that I have the grounds of comparison for this video, I need a method of comparison. And what I'm going to do is explain and count the steps that would be needed to transform IEEE 754 into transreal arithmetic. The steps and count are subject to technical judgments. Different steps and counts are possible because there are different routes of going from IEEE floating-point arithmetic to transreal arithmetic. I'm publicising the steps and counts and putting them into the public record in this YouTube video. I will also link in the description below to a scientific paper that deals with the comparison between IEEE float and transreal arithmetic. If you disagree with my analysis, you are free to criticise it and to propose your own analysis. Let's make a start. Page 4 says this standard does not specify interpretation of the sign and significant fields of NaNs. Transreal arithmetic specifies both the sign and magnitude of nullity, and that's two differences. The significand corresponds to the magnitude. So I'll count those as two differences. On page 5 we read NaN, not a number, a symbolic entity encoded in floating point format. So the letters NaN stand for not a number, it's a symbol, it's not a number. As it says, by contrast, transreal arithmetic operates on numbers and does not operate on any symbolic entity. So I'll count that as one difference. We've now got 1 plus 2 equals 3 differences. On page 5 we read there are two types of NaNs. Signalling NaNs signal the invalid operation exception. Quiet NaNs propagate through almost every arithmetic operation without signalling exceptions. Now, signalling is a computer process that allows programs to be interrupted in order to handle some exceptional case. Transreal arithmetic is completely silent. You just do the arithmetic, no exceptions can arise. And I'm going to count this as one difference. All NaNs are capable of signalling exceptions and no transreal numbers are. So we now have 1 plus 3 equals 4 differences. On pages 6 and 7 we learn that there are 2 to the power p minus 2 NaNs where p is the precision. In 64-bit arithmetic, which is used in most computers today, it has 2 to the power 53 minus 2 NaNs, and that is 9 quadrillion, 7 trillion, 199 billion, 254 million, 740,990 non-identical NaNs. It's a lot. It's an astronomical number. When I started my research, it was 100,000 NaNs for every star in the Milky Way galaxy. Over the decades of my research, telescopes became better, and now it's just 25,000 NaNs for every star in the galaxy. Having that many NaNs halves the accuracy of floating-point arithmetic. Transreal arithmetic has only one nullity. I'll count that as one difference, having one as against many. So now we have 1 plus 4 equals 5 differences. Now, halving the accuracy is a big deal. If you were to base floating-point arithmetic on transreal arithmetic, then you would double the accuracy, even if no one ever divides by 0. Simply using transreal arithmetic will double the accuracy of your calculations. On page 7, we read, although all formats have distinct representations for +0 and -0, the signs are significant in some circumstances, such as division by 0, and not in others. So +0 and -0 are not identical when the signs are significant. Transreal arithmetic has the identity +0 equals -0 equals 0. So all transreal zeros are identical, whereas sometimes floating point zeros are not identical. I'm going to count that as one difference. We now have 1 plus 5 equals 6 differences. On page 11, we read the square root operation shall be provided in all supported formats. The result is defined and has a positive sign for all operands greater than or equal to 0, except that the square root of -0 shall be -0. That means that 0 and -0 have non-identical square roots. But transreal arithmetic has the identity the square root of +0 equals the square root of -0 equals the square root of 0 equals 0. I'm going to count that as one difference, so we now have 1 plus 6 equals 7 differences. On page 14, we read 4 mutually exclusive relations are possible: less than, equal, greater than, and unordered. Transreal arithmetic has no unordered comparison. It has just less than, equal, and greater than. I'll count that as one difference. 1 plus 7 equals 8. On page 14, we read every NaN shall compare unordered with everything, including itself. And that means that NaN sub I is not equal to NaN sub I, and that breaks the law of identity. By contrast, transreal arithmetic has nullity equals nullity, which agrees with the law of identity. I'll count that as one difference, so we now have 1 plus 8 equals 9 differences. Now, breaking the law of identity is a big deal. The law is required in classical logic. It's required in Boolean logic. When you break it, classical logic and Boolean logic do not apply. So, if we think of floating point objects as an abstract data type, then it is not logically possible to specify a floating point program. Neither is it logically possible to test the program. I might mention it's not logically possible to execute it either, but computers don't execute things as abstract data types. They execute them in terms of bits, which remains possible. If you want to specify all of your floating point programs in terms of the bits involved and test them in terms of the bits without using abstract data types, then you can proceed. That is actually done in safety critical systems, but it is exceedingly slow. On page 14, we read comparisons shall ignore the sign of 0, so +0 equals -0. Again, this breaks the law of identity because the behavior of +0 and -0 is not identical. For example, 1 over +0 equals infinity, 1 over -0 equals -infinity, but infinity is not equal to -infinity, therefore +0 is not equal to -0, and that contradicts the equality +0 equals -0. By contrast, Transreal arithmetic obeys the law of identity. I'll count that as one difference. 1 plus 9 equals 10. On page 14, we read the logical negation of x equals y may be written either not x equals y or x is unordered or less than or greater than y. By contrast, Transreal arithmetic has no redundant comparisons. I'll count that as 1 plus 10 equals 11 differences. On page 14, we read the 4 mutually exclusive comparisons and their negations should have 2 to the power 5 equals 32 combinations, but there are only 26 in the standard. By contrast, Transreal arithmetic has no missing comparisons. And I'll count that as 1 plus 11 equals 12 differences. Now, putting the last comment together with this one, we see that floating point arithmetic is missing comparisons and some of its comparisons are redundant. Comparison ordering in floating point arithmetic really does not work. On page 16, we read the exceptions that do pertain to infinity are signalled only when infinity is an invalid operand. Transreal arithmetic has no invalid operands. I'll count that as one difference, so we have 1 plus 12 equals 13 differences. On page 18, we read the following operations are invalid. I'll unpack this a bit. It says plus infinity plus minus infinity is invalid. It says that minus infinity plus infinity is invalid. In other words, infinity minus infinity is invalid. The standard also says that plus or minus 0 times plus or minus infinity is invalid, plus or minus 0 divided by plus or minus 0 is invalid, and plus and minus infinity divided by plus and minus infinity is invalid. Transreal arithmetic has no invalid operations. I said that on the previous slide, so here I'll count it as 0 differences. We'll just keep the 13 differences we've already got. If you want to count these examples of infinity and 0 arithmetic as differences, you are free to add those 16 differences. If you go down that route, there are a lot more differences you need to add, not least the 9 quadrillion differences of the NaNs. On page 19, we read if the divisor is 0 and the dividend is a finite non-zero number, then the division by 0 exception shall be signalled. By contrast, in Transreal arithmetic, division by 0 has no exceptions. So we'll count that as one difference. 1 plus 13 equals 14. In summary then, the claim that Transreal arithmetic is the same as IEEE floating point arithmetic is a lie. Anyone who has read the standard and read the papers on Transreal arithmetic knows that both their history and content is different. The claim that NaN equals nullity is a self-evident lie, because for all x it is the case that NaN sub I is not equal to x. You have to have completely misunderstood floating point arithmetic if you think it's possible that NaN equals nullity. And the claim that Transreal arithmetic is plagiarised from IEEE 754 floating point arithmetic is a lie. As I said, if you have read the standard and you have read the papers on Transreal arithmetic, you know that their history and content is different. Now I have to admire the liars. They are saying that 9 quadrillion things, NaNs, are the same as one thing, nullity. That makes them astronomical liars, or it makes them astronomically incompetent. It would be much better to be totally brilliant, share this video and subscribe to the Transmathematica channel.